Okay, today we're going to do experiment 5. Experiment 5 is thermochemistry. We are going to calculate the delta H of two different reactions. The first one we're going to do is HCl with NaOH. So an acid plus a base gives salt and water. And the second one we're going to do is magnesium plus HCl. That's going to do a single replacement reaction. All right. So we need a calorimeter in order to find the heat of a reaction. So a calorimeter, this is going to keep all the heat inside. This calorimeter is 2 styrofoam coffee cups with a lid that is just a piece of cardboard. All right, and so that's going to keep all of the heat that is generated by these two reactions inside, and that is going to then be detected by an increase in temperature. All right, so I've kind of given it away that both of these reactions are going to release heat, and it's going to then get hot inside. It is an exothermic reaction. Temperature is going to rise. All right, if it were an endothermic reaction, then we would mix the two things together, and then the temperature would go down. Both reactions that we are doing today are exothermic reactions. All right, so the first one is going to be HCl with NaOH. And they are both the same concentration, 1.00 molar. So we have our HCl on this side and our NaOH on the other side. I have measured out of the HCl is 50.3 milliliters of HCl, and the NaOH is 52.9 milliliters. The temperatures of both of these, they've been sitting in the lab all day, and they are both at 19.0 degrees Celsius. All right, and so now we're going to mix them, and we're going to monitor the temperature change. All right. So I will add my HCl. All right, and then once I add my NaOH, I'm going to get my stopwatch going here. And we're going to monitor the temperature every minute. All right, and so I'm going to add this, put the lid on so the heat does not escape, push, go, and then put my thermometer inside, and I will get a temperature. Again, we are starting at the initial temperature is 19.0 degrees, and make sure it's all mixed up nice. All right, so it started at 19 degrees Celsius. We're going to run this until the temperature starts leveling off and going down a little bit, or at least just make sure it's leveling off. All right. Then you will have to graph this data, and I will show that on the board, the correct way to graph for this experiment. All right, we are at the 1 minute mark. At the 1 minute mark, we are at 24.0 degrees Celsius. All right, so far our temperature has gone up 5 degrees Celsius. We started at 19, it is now at 24. So again, it's an exothermic reaction. It's giving off heat, and then that heat is going into the solution, and the thermometer is in the solution, and it is detecting that heat evolved by a temperature increase. Up on the 2 minute mark. It is still at 24.0. So it has not moved at all from the 1 minute mark to the 2 minute mark. This is going to be a pretty boring graph. It's just going to go straight across at the 19, and it's going to go straight across at the 24, which makes this a very, very simple graph to make. I will talk about how the graph sometimes looks and will most likely look for our next one. But this one looks to be very simple. It is still not changing at all. And so it looks like we're going to be at 24, stuck at 24, even at the 3-minute mark. It is still 24.0 at the 3-minute mark. All right, and so that is enough data for this one. It's not going to change. So our initial temperature is 19. Our final temperature is 24. Now, we mixed 50 mils plus 50 mils. Inside there, we have, when you add these two up, 103.2 milliliters of water. You have 103.2 mils of water. I just added the 50.3 to the 52.9, and that is then the volume. The volumes are additive. That's how what the volume is. All these solutions have a density of 1, and so that volume in milliliters is also the mass in grams. All right, well, I'll go ahead and take the 4-minute mark because we're there, and we are still at 24.0. So even at the 4-minute mark, it is 24.0 degrees Celsius. So now we're ready for our second experiment. All right, I will let this one go over here. And so let's go ahead and use this one again. So this time we're going to take magnesium. All right, and so it says between 0.2 and 0.3, so I have weighed out 0.2658 grams. So 0.2658 grams of magnesium have been measured. I have not gotten my HCl yet. The HCl, it says about 70 mils of HCl is to be added. So I will fill it close to the 70 mil mark and then give the actual amount of 1.00 molar HCl, which is a 71.5. Check that down here. 71.5 mils is correct. 71.5 mils. All right, and so I'm going to reset my stopwatch. All right, and get ready for the next one. Rinse this off. Again, my starting temperature of the HCl is 19 degrees Celsius. So I add my magnesium. Right, then once I add my HCl, I'll start my watch. Stop. Okay, starting my timer. And on my thermometer again, I started at 19. So I hear the bubbles. This reaction is generating hydrogen gas. Up on the 1-minute mark. So again, we're starting at 19.0 degrees Celsius. And at the 1 minute mark, we are at 25.0. So 25.0 degrees Celsius is our temperature at minute 1. Again, the temperature is going up because this is an exothermic reaction, the single replacement reaction of magnesium with hydrochloric acid. All right, and this one is not going to be a simple graph to do because the temperature is not at 25 anymore. It is continuing to rise as the magnesium continues to react. So we're going to wait for this to level off at a temperature, and then if the calorimeter is working correct, it'll stay there. All right, 2 minute mark. We are at 29.2. 29.2. So at the 2 minute mark, we are at 29.2 degrees Celsius. It is still bubbling, it is still reacting, I can hear it, and the temperature is still rising. So we may have to go at this for a few more minutes before the reaction stops going and the temperature stops increasing. All right, it's not increasing as much as it was before. So at the 3 minute mark, which is now, we have 31.2. 31.2. And it is still going up. It is not going up near as fast. First one went up 4 degrees. This one only went up 2 degrees. We'll see what. So it's not going up as fast. It's still reacting. I can still hear it. Now, when you had the two liquids reacting, they're both, again, liquids, and they mixed and they reacted immediate. This, you have a solid, and the solid is going to take a longer period of time to react, and so the reaction is going to go longer and longer, and the temperature is going to keep rising until the reaction has completed. All right, and at the 4 minute mark, we are at 32.5. degrees Celsius. So the 4 minute mark is 32.5. I still hear reacting. All right, moving up to the 5 minute mark. Five minutes, 33.3. So temperature is now 33.3 degrees Celsius. It is still rising. It is still bubbling. All right, right, at the 6-minute mark, we are at 34.0. degrees Celsius. I still hear a little bit of bubbling. It's still reacting. We must be getting close to the end of this reaction. Temperature is not going up anymore. Maybe a little. We'll see here. We're moving up to that 7-minute mark. Oh, yeah, slightly up. All right, and so at the 7-minute mark, we are at 34.2 degrees Celsius. All right, 8-minute mark, we are still at 34.2. I do hear some bubbling, but very, very, very small amounts. So this reaction is about over. All right, at the 9-minute mark, we are at 34.0, so now it is going back down. We need a couple more data points for our graph. So it says to go for like 12 minutes. I guess we should probably go for about 12 minutes. All right, so we have 9 minutes so far. All right, so we need 3 more data points, and then we're ready to make our graph for our report sheet. All right, the 10-minute mark, we are holding steady at 34.0. Not a very exciting lab, watching the thermometer for 12 minutes. All right, let's see. So our calorimeter is working pretty well. I still hear a couple of bubbles, but it is holding its temperature at the 34 degrees Celsius. Still, all right, reaching the 11-minute mark. 11-minute mark, we are still at 34.0. And then our last data point. Here are a couple of bubbles, but it is pretty much the reaction has been completed. And our temperature is still not changing. All right, we're moving up to the 12-minute mark. 12-minute mark, we're still at 34.0. So not very exciting, 34.0 degrees Celsius. It hadn't changed from the 9 to 10 to 11 to 12 minutes. So, all right, so that is it for data. Let's go look at our calculations that we need for this lab. All right. So again, we are experiment 5, thermochemistry. All right, so whenever you're doing thermochemistry, you have heat gained is equal to heat lost. So the gaining of the heat is from your solution. The solution is getting hotter, and we're detecting that with a thermometer increase in temperature. All right, and so the heat lost, it's an exothermic reaction. It's giving off heat, and it is being gained by the solution, which is increasing the temperature. All right, so we are assuming in this lab that our calorimeter is not going to lose heat to the surroundings. All right, so we're just going to say, and it's not really a bad, but it is an assumption that is going to lead us to some error. This calorimeter is not perfect, but for our data here that we have, it's going to be sufficient to get a decent answer. All right, so again, the first reaction was your HCl with your NaOH. That is a double replacement reaction. Also a neutralization. So you have many different types of double replacement. This one is an acid plus a base giving salt and water, which is a neutralization. So you got your HCl plus your NaOH yields your NaCl and H2O. The second reaction that we did was a magnesium plus HCl. I have balanced the reaction for you. And this single replacement is also an oxidation reduction reaction. So your magnesium plus your two HCl's give you your MgCl2, magnesium chloride, and hydrogen gas. So the bubbles that were coming out that I was hearing, that was hydrogen gas being released. So the magnesium is going from an oxidation of 0 in the metal solid form to a magnesium plus 2 in the MgCl2 form. All right, and so we have oxidized, magnesium has been oxidized from a 0 oxidation to a plus 2 oxidation. And your hydrogen in HCl is plus 1, that is H+, that is your acid. It went from a plus 1 to the oxidation number of hydrogen in hydrogen gas is 0. So it has decreased. It went from a plus 1 to a 0. So that is your reduction half reaction. All right, so your single replacement is also an oxidation reduction reaction. All right, so for our calculations, we have heat gained is equal to heat lost. And so again, the heat gained is by the solution. The heat lost is by the reaction. And so when you have a heat lost, you put a negative Q. And so Q is equal to negative Q. Heat gained is equal to heat lost. Now to find that value for Q, we're going to take ms delta T. So your Q, which is your heat in joules, M is going to be your mass in grams, S is a specific heat, and for these solutions, the specific heat is 4.184, the same as it is for water. All right, so our concentrations of our acid did not change our specific heat of the solution. All right, and then your delta T is just a change in temperature, temperature final minus temperature initial. All right, and so our density of all of these solutions is 1, just like the density of water is 1. All right, and so we're going to use 3 sig figs for the density, so it is 1.00 grams per milliliter, which means that the mass of the solution is equal to the volume of solution. So, and again, when you had your HCl and your NaOH, you simply add up the 2 volumes in milliliters, and that is the same as the mass in grams because the density is 1. And so that will give you your mass number of your solution. 4.184, that's your specific heat. And now you just have to do your temperature change. And for the first one, I remember it, we went from a final temperature of 24.0 from an initial temperature of 19.0. All right, and so your mass is positive, your specific heat is positive, your delta T is positive, but note that that is of the solution. That is equal to negative Q. So when you solve for Q of the reaction, it is going to give you the negative value of the MS delta T. So again, you put your mass of solution just by adding the 2 volumes. Since the density is 1, multiply it by 4.184. You take your temperature final minus your temperature initial, and that is equal to negative your heat of reaction. And so your heat of reaction for both of these are going to be a negative value because both of them the temperature increased. You have a positive delta T on the left side, and mass is always positive, specific heat is always positive, so you have a positive number, but that's equal to a negative Q, and to solve for Q you have to multiply both sides by a negative 1. Now we're going to be looking for the delta H, which is your heat of reaction, and the difference is it is the Q value divided by moles. And so we have the heat of reaction it's going to be in kilojoules per mole, just like we look up in the charts. Delta H is always given in kilojoules per mole. All right, and so since the Q of reaction is going to be negative, delta H is also going to be negative. This is an exothermic reaction. Delta H is negative. All right, and so you will have to calculate the moles of each reactant, and you will either do that, like magnesium was a solid, we have a mass divided by the molar mass, that will give us moles. For our acid and base, it is simply the molarity times the volume is going to give us moles. But note, molarity is moles per liter, and so volume must be converted to liters in order to get moles. All right, and so then the smaller number is going to be your limiting reagent when you're doing your first reaction, which is HCl and NaOH. Since it's a 1-to-1 mole ratio, simply the smaller number of moles is your limiting reagent, and you simply put that number in and you will calculate your delta H. You will have to calculate which of the 2 reactants is the limiting reagent. So you will find your moles of magnesium and then calculate how many moles of magnesium chloride could be formed. Then you will find your moles of HCl and then calculate how many moles of MgCl2 can be formed. The one that forms the smallest amount of MgCl2, that is your limiting reagent, and then you put that number of moles in for N to find your delta H of reaction. All right, so now you will have to turn in 2 graphs. The first one is going to be relatively simple because we didn't have any temperature change. We simply started, down here was the first one, we simply started with our HCl NaOH at 19. That is labeled as temperature initial. And then we mixed, that's HCl and NaOH, the same temperature at 19. Then we mixed them. And so after mixing, it was 24. This is showing a decrease in our temperatures, but apparently our calorimeter was very good and it just stayed straight across at 24. And so your temperature final is going to be 24. Now, in order to find it, you would have to extrapolate, but since we only have one number for initial and 24 every time for the final, it is 19 for initial, 24 for the final. Now, when we're doing the magnesium and your HCl, what you're going to find is a different story. Our initial temperature is still at 19, but we have many different data points. All right, we go about, 12 minutes on that. And so you're going to have to make a graph showing all of those points on the graph. And then you're going to have to extrapolate back to the time of mixing. All right, and so here is an example of some data where you have your temperature is still increasing as you are doing the reaction, and then it levels off. And then you will have to extrapolate with the dotted line, extrapolate back to the mixing point to see what your temperature final is. Your temperature final is always higher than your highest temperature. It can be the same as your highest temperature. Down here it was all 24, so it's 24. Up here it is going to be the same. It should be higher than your highest temperature, because what we're doing is we're saying here, we're extrapolating back, if all the magnesium immediately reacted, what would have been the temperature, okay? And so that's what we're going back to, that final temperature. We didn't really have to do that here, because as soon as the HCl and the NaOH mixed together, they immediately reacted and we had the same temperature. Here the magnesium was reacting for about 10 minutes, and so our temperature was increasing for about 10 minutes. All right, when we extrapolate back, that's going to give us the temperature. If all the magnesium immediately reacted, that would have been our temperature. So it's going to be higher than the highest temperature recorded. All right, and that is the end of experiment 5.